All right, folks, it's Bass Action, back in action here. In this video, we are going to go through a quick review of the distance formula, midpoint, slope, and writing equations for lines and the various options we have for the equation of a line. Now, some of you might have seen these proofs before, and for some of you, these proofs may be brand new, but it is important to touch on these two proofs here at the top, most particularly the distance formula. All right, on our distance formula, when we want to think about finding the distance in the coordinate plane, really all that we're going to be thinking about is the Pythagorean theorem, okay? You're going to hear me say a lot that the distance formula, the Pythagorean theorem, and a little down the road, the equation of a circle, are actually all the same equation over and over again, just slightly rearranged. So let's say that we have this segment right here and we want to find the distance between these 2 points. Now we're going to write this in a general term. So point H I'm going to label is x sub 1 comma y sub 1, and point E I'm going to label x sub 2 comma y sub 2. Now, if we want to find their distance D, what we can do is we can visualize a right triangle. So I'm going to draw this in a nice little dotted way here, and we're going to visualize this right triangle. That means that we could do the Pythagorean theorem on this right triangle if we can find an expression for each of the legs. So on this horizontal leg here, what I would do is I would look at these two x values and I would need to find the distance between them. Now it doesn't matter which one you subtract first, that makes no difference in our formula. We just need to be consistent. So I'm going to say x sub 2 minus x sub 1 because that's our most traditional way to see it. Then we're going to do our vertical leg as well, and now we'll look at the y values. So we'll do y sub 2 minus y sub 1. From here, we can just drop everything into the Pythagorean theorem. So our hypotenuse squared in this case is d, so we'll say d squared. And then we're going to square our two legs, so x sub 2 minus x sub 1 squared, plus I'm going to go into my other part here, that's okay, y sub 2 minus y sub 1 squared. So our distance itself is simply taking the square root of each side. So our distance formula is the square root, and we're going to give ourselves a big square root here, and we're going to say x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So hopefully this is going to help you remember why each of these terms need to be squared, why they need to be subtraction inside those parentheses, and why this is a plus, because the whole thing is really the Pythagorean theorem. Now, on our midpoint formula, what we want to remind ourselves, again, we're going to label these ordered pairs, x sub 1, comma, y sub 1, and y sub 1, comma, 2, comma, x sub 2, sorry, got ahead of myself there. I'm going to do my x sub 2, if I can get my pen back. There we go. X sub 2 and y sub 2. So if we want to find the midpoint, recall from our geometry days, we would mark those two segments congruent. And remember, midpoint is simply an average. So we're going to average our two x values. Average is simply add them together and divide by 2. And since an ordered pair has two parts, we need to do the y's. So we're going to average the y's. Y sub 1 plus y sub 2 all over 2. So you're just going to find their average. Now, I like to do these side by side, even though midpoint is super simple, because students often confuse which one they add and which one they subtract. So this should give you something a little more concrete. Now, real quick review of these formulas with some numbers that are going to be slightly more complicated than you've seen before, and one that's just a review from your geometry days, but you may have forgotten. Notice I'm going to throw in an ordered pair that has a fraction in it. We do not want to convert those fractions to decimals because we're not going to have our calculators handy for us on these tests. The next thing is that on our distance formula, you'll notice I use this slightly different notation. This is a little more advanced way of just saying we are going to find the distance d, and it's going to give us the two ordered pairs from A to B. So you need to understand this notation. You'll notice that I've already set this up for us because I didn't think that was necessary for us to have that written out in the video. So you might need to pause and jot this down. And then I'm going to walk through how to handle this with the fractions. Now, what we're going to do, you can see that I've done the difference in my x values, so 3 minus the 5 halves, and I squared it. I added. I did 1 minus my -2, so I jumped straight to the plus, and I squared it. Now, within this first parenthesis, we're going to need to get some common denominators. I personally still like to write down that over 1, and then I like to jot down what my common denominator would be. So I'm really doing 6 halves minus 5 halves, and that's where this 1/2 came from. Now I'm going to still need to square that in a moment. My 1 plus 2 gave me my 3. Now, when I go to square this fraction, it's important to remember that when we square, we multiply by itself. So my 1/2 squared is going to become 1/4, and then my 3 squared is going to become 9. So once again, I need to get some common denominators. So I'm going to jot that over 1. I'm going to put a nice 4 over 4. It's going to make it a little easier for me to add those fractions. Scooch this up here a bit. Now, when I add those fractions together at this stage, now I'm going to have the distance is equal to the square root, and I've got a 1/4 plus a 36/4, so I have 37/4. When I go to simplify this, what I'm actually going to do is I'm going to have the square root of 37 over the square root of 4, which gives me a distance of the square root of 37 over 2. Now, on our midpoint formula, I did not include just a basic midpoint because truthfully that's too easy for you guys. You already know how to do it. But I wanted to give you a little reminder of how to work backwards. When we read this problem, what you can see on this problem is that I'm telling you that A is going to be the end point of some segment. So I took my ordered pair for A, and we can see that I stuck it right there, that 3, 1. But now I'm telling you that B is actually going to be the midpoint of this segment. So instead of putting B all the way on the other end, I put it in the middle. Now, I don't know what the other end point is. That's the point of the problem. So we're going to find that, and we're going to use our midpoint formula backwards. So I'm going to start with the x values. We're going to do this twice. We know that we got this middle value here of 5 halves for x by finding the average of these two x's. So what I'm going to do is say x plus 3 over 2 equals 5 halves. Now, this problem is a little easier to do because my denominators are already the same. If you didn't have that, you would want to cross multiply, as you'll see in just a second. But since my denominators are 2, I can look at just this numerator and I can see that really what I'm just trying to answer is x plus 3 equals 5. So my x coordinate for my endpoint should have been 2. I'm going to repeat the process with the y's. Then I've had the average of these two y values gave me this -2. So now I'm going to see that y plus 1 over 2 had to equal a -2. And here's where I was talking about that cross multiplying. I don't have the same denominator on each side, so I'm going to put the right side over 1 and cross multiply. When I cross multiply this, I am going to end up with y plus 1 equals a -4. So my y coordinate that I need is a -5. Okay? And if you find the midpoint using these two ordered pairs, you should get right back to that. Last thing that we're going to do is slope. We need to remind ourselves that slope is rise over run. So we're just going to find the slope of our 2 points for A and B. Remember, slope is a subtraction. It's the change in x, or change in y over the change in x. So I'm going to do 1 minus the -2. That gets me right back to that 1 plus 2 that I had earlier. And I'm going to do 3 minus my 5 halves. Again, I'm back to needing to think about those common denominators. So as I simplify this, my numerator becomes 3. My denominator is 1/2. Now, lots of you can probably figure out that 3 divided by 1/2 is 6, but if your brain's a little like, I don't know what to do. Remember, you can do 3 times the reciprocal of 1/2, which would be 2, and that's going to give us a nice slope of 6. Remember, m is our notation for slope. All right, the last thing that I'm going to do on this quick review of our some basic algebra is our 3 forms of a line. Point slope form, this one is actually going to become extremely critical for us. So if you're not really familiar with point slope, you need to get familiar with it now. We're going to write an equation for a line specifically in this point slope form, and we want it to be perpendicular to this given line passing through this point. So the first thing that we want to do is we want to look at the given line and identify what is the slope. And the slope of that line is 3. It's just this nice coefficient. That means that the perpendicular slope is going to be the opposite reciprocal, or a negative 1/3. Now, the point slope form of a line is going to be y minus, I'm going to say y sub 1, and my slope, and x minus x sub 1. So we just need to substitute, and then we're going to be done. So we're going to say y minus the y point that we're given, y coordinate, the slope that we want of a negative 1/3, and then x minus my x coordinate that I need to use is a plus 9. Now, often students don't read this carefully, and I ask for point slope form, and they keep going, and then they have to do a whole lot more work than is necessary. Our next form is slope intercept form. This one is really nice if you need to graph, okay? We can graph from point slope, but this one is the one that we're most familiar with. So just a really quick reminder, our slope on this problem is going to be a -2, and the y-intercept, specifically it's the y-intercept, we would often identify as just 8, but I'd like you to get in the habit of remembering to write intercepts as ordered pairs. So let's remember to write that as a 0, 8. The last thing that we want to look at is the general form, and I'll be honest, I don't find the general form to be particularly useful most of the time, but it looks really pretty. I will tell you that this form is really nice if we want to quick find the x and the y-intercepts. We can quick find the x-intercept by letting the y equal 0. So if we want to find the x-intercept and y is 0, then this whole term drops out. It's just gone. So we're left with 15x equals 2, so I get 2 over 15, and again, we can write that as a nice ordered pair, 2 over 15, comma 0. The same thing could be done for the y-intercept. We can just make this whole term disappear because x will be 0, and we're going to get a negative 10y equals 2, so y is going to be a negative 1/5. And again, we could write that as a nice ordered pair. Okay, this should have felt like a lot of review. My 5 doesn't look very good there. This should have felt like a lot of review. If it does not, jot down your questions that you have, and we will talk more in class.